Hey, 7th grade, Miss Dawkins here. This is an experiment for Lesson 6, Osmosis. We began talking about osmosis on last week. Osmosis is the movement of water molecules from an area of higher concentration to an area of lower concentration. This is done through passive transport, which means that the water molecules are going to move on their own without the help of any energy. The title of this experiment is going to be the egg experiment. And in fact, I have 2 eggs here. Now, this experiment is actually a little complex. It's going to have to be filmed at about 3 different times. This first video is not actually going to show us osmosis. It's just going to set us up for the experiment, but I think it's pretty cool, so I recorded it anyway. I have these 2 eggs in this bowl. The bowls are empty, but I'm getting ready to pour vinegar into each bowl. I'm going to leave these eggs soaking in this vinegar for 24 hours. I'm not going to tell you what's supposed to happen. And in 24 hours, I will come back to you with the second part of the experiment, which is going to show us something about osmosis. All right. So we're just going to let these sit. Already now, I don't know if you can see. I guess I can push it closer. The egg is starting to bubble. I wasted a little, but it's okay. Hopefully you can see. The egg is bubbling. So you can tell something's happening here. I look forward to reaching out to you in the second part of this video to show you what exactly is going to happen.
24 hours later.
Hey, 7th grade. This is part 2 of the egg experiment. In front of me, I have placed a cake plate over the eggs because we soaked the eggs in vinegar for 24 hours. And it smelled so bad I couldn't sleep last night. So I had to come and put something over it. Hopefully it's not going to mess with our results. But it did help with the smell. I did not touch them other than putting that cake plate over them. So we let our eggs soak for 24 complete hours. Something I forgot to tell you all on yesterday. These eggs were raw. I did not boil them. They came straight from the refrigerator into these bowls of vinegar. So, pulling them out, it's kind of foamy. I'll let you see. It has turned into a jelly egg. I can smush it. I'm not going to smush it too much because I don't want to bust it. We need it for part 2 of the experiment. I have bowls. And this is the second one. So it's so cool. The shell completely dissolved. I carefully clean my hands and the egg so you can see what it looks like. It still has a little bit of the shell. Well, if I rub it, it kind of rubs away. But I don't want to rub it too hard. I don't want to break it because we need it for part 2 of the experiment. And then we have the other one. So, again, part 1 of the experiment did not have anything to do with osmosis. So now we're getting ready to get into the osmosis part of the investigation. So I have 2 liquids. I have water and I have corn syrup. And I'm going to pour these 2 liquids into the bowls. Let me back them up a little bit so you can see them. And we're going to let them soak for 24 hours. Now remember, osmosis is the movement of water into and out of a cellular membrane. So after we let these eggs soak for 24 hours, we're going to observe them and we're going to find out which one is going to be hypertonic and which one is going to be hypotonic. Now, hypotonic means that it's going to swell, it's going to take in the water. Hypo will blow. That's the saying I learned to remember it. So hypotonic will blow. If it gets too big, then it can burst. And then hypertonic, it will shrink. You have to figure out which liquid is going to make the eggs hypertonic or hypotonic. Now, I have here with me a ruler so that I can measure the size of the eggs. So this first egg, and I'm going to measure it in centimeters. And I'm going to upload a picture so you can see for yourself the measurement of egg A. So I'll label it before I take the picture. Egg A is going to be soaked in corn syrup. And it's measuring at I'm going to do it at 6 centimeters. Now egg B, let me dry it off a little, just so it's easier to work with. I don't want to drop it and bust it. This is egg B. Egg A has been labeled. Egg B, I'm going to make a tag for. Egg B will be soaked in water. Just going to use plain bottled water. And I'm going to say, and again, you can argue with me in the comments professionally if you don't agree, but I'm going to say that egg B is also measuring at 6 centimeters. And I'll insert a picture for egg B. Okay. So, now that we have both of our eggs measured, we're going to say that they're both 6 centimeters after soaking them for 24 hours in our vinegar to allow the hard shell to dissolve. So now, getting ready to start the 24 hours of soaking one egg in corn syrup. I started off pouring it on top of the egg. I don't know if you could hear that little noise it was making. And so I then decided to just pour it on the side. I got a little afraid. I don't know. I want the egg to last for 24 more hours. And then here's the water. It also kind of made a little noise when the water poured on top of the egg. I also got a little afraid and did not pour it on top. But it's okay. So we have our eggs, and I'll turn it so that the tags are facing me. So this is water, this is corn syrup. We're gonna let them soak for 24 hours. And I can't wait to come back to you with part 3 so we can figure out which egg is hypertonic and which egg is hypotonic.
24 hours later.
Hi there. This is part 3 of the egg experiment. So I'm getting ready to show you the results after the 2 eggs soaked. I was going to let them soak for 24 hours, but I lost track of time. So they have actually soaked for 27 hours. That will be 3 additional hours. Alright, so this is the egg that was soaked in corn syrup. And this is the egg that's soaked in water. So I'm going to pause here and give you a view of the actual eggs from in the bowl, and then I'll come back. Alright, so this is the view of the eggs in the bowl. This is egg A. It's in corn syrup. It started at 6 centimeters. And I'm going to get it out in just a moment to measure it. If you look at it, the skin on the egg is kind of shriveled. It's going to be my first time touching it. And if you know me, I don't like to touch stuff like this. But here we go. Yeah, it has like a little shriveled, wrinkly skin. So you can definitely tell that this egg shrunk. Egg B is here. This is the egg that has been soaked in water. It also started at 6 centimeters. If you can see, it's very plump. It's still a jelly egg. You can't see the yolk in this one as well as you can see the yolk in this one. Let's look at them side by side. Alright, so let's dig them out and see what they look like outside of their liquids. And let's measure them. So we're going to start with egg A, the egg that is in corn syrup. I just got to do it. I don't really like touching things like this. So this is the egg from the corn syrup in my hand. Has just a little bit of shell remaining on it. All right, let's get a measurement. So you can take a look for yourself. I marked it here at the bottom at 0 centimeters, and I marked it at about 4.5. So I think it's about 4.5 centimeters. We started at 6 centimeters. So that means that our egg shrunk about 1.5 centimeters. All right, so when I measure egg B, I feel like egg B is still coming out at 6 centimeters. Let's get an up-close view. I just measured egg B, and I'm still seeing 6 centimeters, which makes me wish now that I had taken the weight of each egg at the beginning of the experiment, because we're not getting to see the change in egg B. It's clearly bigger. It's more plump. It's definitely bigger than egg A, but we're not sure what the change was, what the exact measurement for the change in the egg was. It was still a cool experiment, and hopefully you all enjoy watching it. Now, the assignment for the 7th graders. I need you to write me a 1-paragraph response, 5 to 7 sentences. Which egg is hypertonic and which egg is hypotonic? If you need to refresh your memories on the differences, check out my previous videos and write your response. Remember, this is egg A, and this is egg B. Ta-ta for now.